Hello, my name is John. I'm taking you through the course Programming with Java. Like we started at the time online and we had issues. As agreed, I am recording my screen and then I'll share this video with you. The major content we're looking at will be the introduction and then why we need to program, computer systems, and then we look at hardware and software component, but in relation to software development more. And then we also look at some programming languages, specifically putting more emphasis on Java, and then what a program is made up of. And then we look at the programming processes, and then we also look at finally the object-oriented principles for this particular section of the video. Quickly, now we're looking at the history of Java. Java started with a development in 1991 by a green team in a subsidiary of Sun Microsystems. Um, Now Java is owned by Oracle. Sun is one of those very old old platforms where Java applications were created from. So as at the time I was in school and learning how to program in Java, that was the tool I used. The Sun, it was called Sun One, and it has several other packages. So then, apart from programming in Java, you could also program in C, C++, and some other languages. Now, in making progress, they also developed the Star 7. This was meant to control multiple entertainment systems. From this side, that is where the essence of Java actually comes to play. The handheld controller, which is supposed to be used to control multiple entertaining systems, you would agree that every hardware has its own software that it uses. Every software has its own standards. So moving from one hardware to the other, the standard of the software that needs to run on it begin to differ. Okay, so Java is developed in this perspective to solve this gap that comes in. So we're looking at a software that can run on every other kind of platform. Okay, so you would understand that Java, as it stands now, is capable of running on multiple platforms without difficulty. So if you have, for example, the Mac OS, Linux, Ubuntu, or whatsoever it may be, it is practically capable of executing. You will not need to do any further tweaking on it before it will work out correctly. So you would find in some other books giving this an attribute as the platform independent or architectural neutral. That is what gives Java this attribute. Um, Earlier on, Java was named as Oak before the, the standing name now given to it as Java. We all know what web browsers are. Web browsers help us to find resources on the internet. What made it more interactive, it's in the introduction of Java. So it was a Java plugin called Hot Java. It was embedded into the browser, making it more interactive. And then this was demonstrated in 1995 during the Sun World Conference. And then Java was also incorporated into the Netscape. Netscape is also a kind of a browser. It is now out of date, no, not much in use, but it was one of those first web browsers that did deploy the use of Java into it to also make it much more lighter and then interactive. So, like I mentioned earlier on, because Java can now run on multiple platforms for which you will not need to do any additional functionality, it has the attribute as cross platform, meaning that they can run on various computer operating systems. So whether Ubuntu, it is Linux, it is uh, Mac, or whatever kind of operating system that it may be. Java is capable of running on that. Now we're going to look at um, the major types of divisions that we have in the Java programming language. We have what to call the Java applications, and we have the Java applet. What's the difference between the Java applications and the Java applet? The Java applications are literally meant for desktop applications. So they are standalone programs that run without the aid of the web browser. It doesn't need the internet, it doesn't need the browser to be executed, because your focus is not to develop the application to be used online. Also, it has some relaxed security model since the user runs the program locally. You don't really, if the program is going to run online, that is when you want to think of how to provide some security infrastructure where people cannot hack or penetrate into the system with ease. Okay, so in this situation, the security features are much relaxed with the Java applications, as compared to the applet. The applets are actually small applications that require the use of Java enabled web browser to run. So, like we mentioned, the Hot Java was a plugin for a browser that would make it the browser much more interactive. The Netscape browser also allowed a plugin of Java. Um, the Google application we have also allows Java plugin. So all of these ones are Java enabled browsers. Okay, they allow interactivity with each, so our applications can easily load. As the applets, as against the applications, you would agree that whilst the applications they have a relaxed security. The security features in the applets are much more enhanced. They are improved. They are increased the because the application is now supposed to run online. You do not know the people who are going to have access to it, and the intentions for which they would want to use the application for. So definitely, you will need to have improved the the security features. So the basic distinction between the applet, and then the application is that the applications are literally meant for desktop application development, and then the applets are meant to for you to create applications that will run on the internet. These why do you need to program? This is a question for which you already have answer to. The computer system was developed literally to be programmed. So it has a hardware, it has a software. The software is made up of some set of instructions. They are supposed to tell what the computer system will do. So take, for example, the spreadsheet databases, word processing games, and then accounting software, booking, hotel booking software, and the like. They are all instructions. They tell the hardware resources what they should do. Okay, so um, given this background, you would understand that anytime we are using the computer system, it is literally instructions that we are offering. So you may be clicking on your machine. For example, now you have these buttons here. If I click on this red button, it means that I want to close it. If I click on this, I want to minimize it. If I want to maximize the window, I click on this green button. So all of these ones here, as we see in the panel, they are all what? Instructions. So when you have the software on your computer system is literally some set of instructions for which the user would use to interact with the hardware of the computer system. That means that the computer system is made available for subsequent programming enhancement. Okay, so why would you need to still why on the question why program? As part of a computer program that must be designed, the the logical flow of the instructions, the mathematical procedures. Um, when you have a challenge that you need to resolve, that is when there's a software that is supposed to be developed. Every software is looking at a problem that it must solve. Therefore, the logical flow of how your instructions you are going to write will go is very much important. That is what literally you'll be calling that as an algorithm. The instructions we write, we call them algorithms. If you are writing them as codes, then we may call them source codes. Okay. In these algorithms, in these source codes, you may have some mathematical expressions, some formulas that you need to provide. Okay. So these are layouts that you will need to follow that will help that your program, uh, when executed, will run. All right. I will be picky on these ones to mention quickly on user friendliness. Developing the software, the user friendliness of the system is much important. The software can be very good. It is it is performing a lot of technical activities. However, if you do not provide the basic interface that would make it easy to use, then people will not want to use the application anymore. So in development, we would need not to focus only on the very technical side of the application development, but we also need to concentrate on the fact that those who may be using the applications are not as technical as those of us who develop them. So it will need to have a very simple interface, very interactive, and then very much functional. When you do development and then you include manuals, help systems, and other documentation, you hope that possibly even in your absence or with your presence, the updates that need to be made on the system can be easily made. Okay, I will skip these these sites since they are concepts you already know. Now in the computer system, um, you have two main components: the hardware and then the software side. The major component of the hardware relevant for programming, we're looking at the CPU, or what would also be referenced as the processor. In some other books, you may see microprocessor. The main memory is the same as the RAM. Secondary devices, I think you know what secondary devices are. Secondary devices are the devices, storage devices. They are those that are distant from the microprocessor, or more often they are not on the motherboard. So you can take the hard disk as an example, and then the various external storage devices, um, like like the pen drive. The pen drive, they are all examples of secondary storage devices because they are very much distant away from the computer system. You can write instructions that will manipulate all of these external hardware resources. Now, in programming, we'll be looking at the very fundamental input and output devices. The primary input device to the computer system is the keyboard. The keyboard for input, and then the output using the monitor. However, with programming, you would understand that the keyboard is not the only. Sorry, with computing or computing sciences, you understand that it is not only the keyboard for which you can use to give instructions to your computer system. When you develop a graphical user interface, the let's simply put GUI, the GUI can also take input, and then it can give you some reports from the system. So that will be the output, which will mean that the graphical user interface, what we simply calling as the GUI, can also serve as both input and an output component. That is much relevant for programming. And so I will skip these ones are very much fundamental. Okay, so um, let me explain this. In the CPU, inside of the CPU, we have the arithmetic logic unit, and then we have the control unit. Instructions come in as an input, and then the arithmetic logic will do the arithmetic side of it. That is um, instances where the input would involve addition, subtraction, multiplication, finding modulus of two or more numbers. That will be done by the arithmetic logic unit. The control unit um, is made up of some number of registers that will help in the computation and then the control of the entire computer system. Then the output is sent out. Likewise, in programming, you have instructions that will come in. What you write as a source code, it will come hit the CPU, and then we expect the CPU to provide interpretation to, the CPU should execute those instructions that came in and then give out the output. So this is the cycle that it goes through. There is a fetch, getting the instructions from the RAM, and then the instructions need to be translated into their respective meanings and understanding, and then they are executed. This is a cycle that it goes through all the time. The fetch is done, the instructions are fetched from the main memory, which is the RAM, in the exact sequence as the program is organized. So in your algorithm, you may have the start, and then your first instruction to go to the next, onto the last. So fetch means that the CPU is supposed to get the instructions at the very top. So the number one step in your algorithm or in your source code, that is what the microprocessor will fetch from the RAM. Okay, the decoding in the decoding, the ALU plays a key role in here, having to give interpretations to the instructions that were fetched, breaking them down into opcodes and then operands. The operands, for example, will be like the variables. So you take for example, if you have something like A is equal to B plus C. If you have that taken this course, computer organization, you should be able to have a very good idea which of them is the opcode, which of them is the operand. The opcodes are actually the operators. So you see the equal to symbol here and then the plus. It is the plus symbol that is saying that take what is stored in the location B and the location C, add them together, and then move that result into the location labeled as what? A. So A, B, C are the operands. Equal to symbol and then the plus symbol, they are the opcodes. Okay, so in the decoding level, the ALU breaks down the instruction that is fetched into opcodes and then operands, identifying what the operators and then what the variables that are supposed to be acted on by the operators are, and then they are in the next step executed. Okay, so in the programming also, this is the typical structure in which the instruction goes through until the output is given back again on the screen. I would skip those sites that are very much fundamental and not relevant for our discussion. Okay, so on programming languages, programming language is a special language that is used to write computer programs. So you may have heard of C or not like you have heard of. I know you have done C++, and then now we are in the class for Java. All of these are examples of programming languages. What do they do? When you write instructions in C++, in Java, there is a product you are creating. That product you are creating is a software. Okay? So how did you get that software? You got that software by writing instructions in these programming languages. So you use a programming language to create a software. So what we simply say is that, for example, um, the the panel that we have access to now is a panel in Microsoft PowerPoint. Microsoft PowerPoint was developed using a particular programming language. Every software, the operating systems, the utility software, and name it, whatever kind of software that we have, they have all come because of what? Because a programming language was used. So programming languages are literally used in developing software. In having to write instructions in a programming language, we will need to understand very much algorithms. In the elemental programming class, I know you were taught what algorithms are. So the algorithm will literally be a sort of instruction that you would write that when followed, an output would be achieved. Now, when you write any software, when you write any as your source code need to be translated into the machine language, which is more of the time or all the time zeros and ones. Okay. One of the very first kinds of programming languages that were developed is the assembler. The assembler tend to be like an intermediary between a high level programming language and then the low level programming language. So it is not so much easily readable, and then it is also not zeros and ones. That is why it is. I said that it sits in between the two. However, it is classified as a low level programming language. They work more directly with what we call registers. In the introduction, I mentioned that the CPU contains some number of registers. Okay, so when you are using the assembler in writing instructions, you are dealing directly with the hardware resources, specifically with the registers in the CPU. Now, with the high level programming languages, an example are these ones: Java, the basic COBOL, Pascal, C, C++, C Sharp, that are down to JavaScript. High level programming language because they are not written in the language directly understood by the microprocessor. So they are more at the human level. Okay. So when talking of high level languages, we are looking at languages that are at the human level. Okay, so when you write instruction in C++, write something like C out. This, these these characters here are borrowed from the human set of characters that we read, um, for example, in English. Okay, so they are the very much human readable form. If they were to be in the machine language form, then we're expecting some number of zeros and ones, some sequences of zeros and ones. Then we will say that is typically what? Machine language. So at the higher level programming language, we only have the that which is readable in the human readable forms. Okay. So these high level programming languages and even the low level, they are made up of some number of keywords, operators, some point 20s, programmer defined identifiers That is what literally we'll call variables. And then they follow some syntactic rules. Okay, the syntax is the instructions that are given. Sorry, syntax is the rule given to how the instructions are supposed to be written. Okay, so um, for example, in C++, if you want to print, you use printf. The f is supposed to be a lowercase. That is, this entire object here is supposed to be a lowercase. If you capitalize this, you have a syntax error because it didn't follow the structure of your code. So that is literally syntax error. Quickly now we're looking at the structure as it is with the Java programming language. Let me cut this video so then it can be short for me to upload, and then I'll start another one.